Welcome to the final video for Unit 6, Part 6, Trapezoids and Kites. A trapezoid is a quadrilateral that only has one pair of opposite sides parallel. Notice that a trapezoid has four base angles, because if you notice the picture here, the legs are the non-parallel sides, and the base is the parallel sides, and the angles here that are on the base, those are what are called base angles. All right, and there are four of them. An isosceles trapezoid would have congruent legs, and that means at the same time it would have congruent base angles as well. The mid-segment of a trapezoid is a segment that connects the midpoints of the legs. And the last type of figure is what's called a kite, and that's a quadrilateral with exactly two pairs of consecutive congruent sides. So notice the consecutive sides are congruent. So it's not a parallelogram, but it's a quadrilateral that has two pairs of consecutive sides congruent, and that is what's called a kite. So a trapezoid, it just has one pair of parallel sides, and a kite has two pairs of consecutive congruent sides. So a couple theorems from this. If a trapezoid is isosceles, meaning the legs of the trapezoid are congruent, then as I said, each pair of base angles are congruent. If a trapezoid has one pair of congruent base angles, then it is isosceles, meaning if you know the base angles are congruent, then you can say the trapezoid is isosceles. So it's just like the converse. And if a trapezoid is isosceles, if and only if its diagonals are congruent. So the diagonals of an isosceles trapezoid are congruent. So if you look here, it says each side of the basket shown is so each side of the basket shown is an isosceles trapezoid. So here JKLM is isosceles trapezoid. The measure of angle JML, so this whole thing is 130. KN is 6.7 feet. JL, the whole thing, is 10.3. So it wants you to find the measure of angle MJK. Well, MJK is this whole thing right here. And since these are the bases, what do we know about consecutive interior angles? They're supplementary. So 180 minus 130 equals 50 degrees. And since the whole diagonal here is 10.3, and we only know part is 6.7 for MN, we can go 10.3 minus 6.7, and that gives us 3.6 feet. All right, the next question says quadrilateral ABCD has vertices 5, 1. So it gives you all the vertices. Use slope to show that ABCD is a trapezoid and lengths to determine whether it's isosceles. So let's draw it out first. So 5, 1, -3, -1. -2, -3 is down here. Oh, sorry, it's -2, +3. And D is 2, 4. So there's your trapezoid or quadrilateral, and now you want to use slopes to determine it's a trapezoid. So you can use slope. Basically, if you get one pair of opposite sides as parallel, then that's a trapezoid. So the slope of AB is 5, or sorry, negative. It's y2 minus y1, -1 minus 1. And then it's -3 minus 5. So it's -2 over -8, which is 1/4. slope of CD is 4 minus 3 over 2 minus -2, so it's 1/4. So notice these are parallel here, so let's see about BC and AD. BC is 3 minus -1, -2 minus -3, so it's 4 over 1, which is 4. And then the measure, or the slope of AD is 4 minus 3 over 2 minus -2. So it's 1 over 4. So it's 4 minus 1. It's 4 minus 1 and 2 minus 5. I was using the wrong, I was doing D to C instead of D to A. So it's 3 over -3, which is -1. So see, we just proved that BC and AD are not parallel. So that proves that's a trapezoid. Now to prove that's isosceles, we have to find the lengths of AD and BC and show that they are equal. So doing the distance formula, so 2 minus 5 squared plus 4 minus 1 squared. So it's -3 squared plus 3 squared. So 9 plus 9 is the square root of 18. And then BC, it would be -2 minus -3 squared plus 3 minus -1 squared. So you get the square root of 1 squared plus 4 squared. So you get the square root of 17. And so therefore it is not isosceles, since AD does not equal BC. So it's just a trapezoid, but it's not isosceles. All right, the midsegment of a trapezoid, as we said, it connects the midpoints of the legs, and the midsegment is half the sum of the bases. So here, if I'm trying to find the midsegment, if I'm trying to find x, and I'm given that mn is the midsegment, so mn, remember, is equal to 1/2 the sum of the bases, which would be kf plus jg. So it's basically that 30 is equal to 1/2 of 20 plus x. So what I like to do, instead of distributing here, I like to multiply it to get rid of the fraction. So I'll multiply by 2. Multiply by 2. So you get 60 equals 20 plus x. So subtract 20, and you get 40 equals x. So here, WKY is an isosceles trapezoid with midsegment JK. Find XY if JK equals 18. So this is 18 here, and WZ is 25. So we know here that 18 is equal to 1/2 xy plus 25. So if you multiply by 2 to get rid of the fraction, so 36 equals xy plus 25, and then subtract 25, you get xy equals 11. All right, and then the last figure is a kite. So if a quadrilateral is a kite, a couple things happen. Number one, the diagonals are perpendicular in a kite. So you'll have 4 right angles here. And also, if a quadrilateral is a kite, then you have 1 pair of opposite angles that are congruent. All right, so 1 pair of opposite angles are congruent. So here, it'll be the ones where the 2 sides that are non-congruent meet. So notice where the non-congruent sides meet, those 2 angles are congruent. The other 2 would not be congruent. So if WXYZ is a kite, find the measure of angle WZY and XYZ. Well, those are the 2 things we're going to find. So remember that, so 121 is where the 2 non-congruent sides meet. So that means this other one is 121. So WZY is 121. And then remember, it's a quadrilateral, so 360 degrees in a quadrilateral. So if I just make that x, then 73 plus 121 plus 121 plus x equals 360. So this is 242 plus 73. So it's 315 plus x equals 360. And then you subtract 315 and you get 45 degrees. So it's 45 degrees. So if BCDE is a kite, find the measure of angle BED. So BED is right here. And so since this is the one that's formed by the 2 non-congruent sides, BED would also be 130. And then to find the measure of angle CDE, we have to add up. So 130 and 130 is 260 plus 64 is 324. So 360 minus 324 gives you 36. So CDE is 36 degrees. All right. So MNPQ is a kite. Find NP. Well, remember the diagonals are perpendicular, so that gives you some right triangles here. So that means this is, and remember the diagonals also. Remember that you're going to have in this, you're going to have these triangles here are going to be congruent because of hypotenuse leg. So therefore, if this is 8, then this is also 8. So basically the diagonals, these 2 triangles here are going to be the same. So in order to find NP, we'll call that x, we're going to use the Pythagorean Theorem. 6 squared plus 8 squared equals x squared. So 36 plus 64 equals x squared. So 100 equals x squared. So x equals 10. So that means NP is equal to 10. So yeah, so we'll use the fact here that these 2 triangles are going to be the same. So that means 8 and 8. And then this is 6, so we're just finding the hypotenuse. So same type of question here, find KL. So remember diagonals are perpendicular. And since this is 3, this is also going to be 3. So then to find KL, we go 3 squared plus 4 squared equals x squared. So 9 plus 16 equals x squared. 25 equals x squared, 5 equals x. So KL is equal to 5. All right, that concludes our video on kites and trapezoids, and we're done with Unit 6. All right, have a good rest of your day.